Hey everybody, it's Mr. Carr again. Today we're going to be talking about 12.1 day 2. We got a little bit more to do with our trig. The first thing we want to talk about is how do we find missing angle measures with trig. So the biggest thing about this, so in this example, we want to find the measure of angle A. Round to the nearest integer if necessary. So we're going to mark the angle that's what we want to find. So that's what I just did there. We want to mark our hypotenuse, opposite, and adjacent sides, just like if we're doing normal trig. So that's going to be hypotenuse from the angle A. This is going to be opposite, and that leaves this to be my adjacent side. Determine which trig function to use depending on the given information. I have multiple options here. I could do any of the trig I want. Personally, I'm going to avoid the decimal number, so I'm going to use these two. But let's say that this was missing. Okay, let's say that wasn't even there. I'd have to use sine or opposite and hypotenuse. I haven't gotten a sine yet. Okay, but let's say this was missing. Now I have to use adjacent hypotenuse. Okay, so if I have just two side lengths, then I could find any angle inside of a right triangle like that. Okay, so for this one, I'm choosing sine for opposite and hypotenuse. So let me write that out first. So the sine of angle A is equal to the opposite divided by hypotenuse. Now the thing to remember is to find the actual angle measure, we're not going to do cross multiplying. We already have the ratio of 9/17. Instead, we have to do inverse sine. That's the difference in our solving now. So to find a missing angle, we're going to do inverse sine of 9/17. So it just goes into my calculator just like that. So when I do that, I'm going to get, as it says here, we want to round to the nearest integer. So what I get is approximately equal to 31.97, but then I'm going to round it off to 32 degrees for my nearest integer. Okay, that's inverse sine. Again, as long as we have two sides of a triangle, we can set it up with our normal trig ratio, and then we do the inverse version of that. That's what happens to get our missing angles. The last thing to cover today is talking about kind of our word problems in terms of angles of elevation and depression. So remember what it means for an elevation depression idea. So for example, let's say I have a guy standing at the bottom of a hill and I have another guy standing at the top of a tower. Right there. Okay, so if they're looking at each other, we can kind of treat it as this triangle shape here. Okay, and instead of a dash line, let's do this. We can kind of create this triangle shape between the two looking at each other. Here's the idea. If I were to draw a straight line a straight line horizontal line like that, this is the angle of depression. Okay, so angle of depression here. So that is referring to this person's version as they look down. The angle of elevation is this person looking up. Okay, so look at how that in terms of my triangle, one of the angles is inside the triangle and the other angle is outside the triangle. But one key thing that's interesting about this is that this angle of depression, angle of elevation, these are actually always the same. These are going to be congruent to each other when they're looking at each other like that. So that's helpful depending on the type of word problem we're dealing with. So for this one, we're going to set this up as the hill of a roller coaster has an angle of descent or an angle of depression of 60 degrees. Its vertical drop is 195 feet, and that's referring to this value here. From a blimp, the apparent distance traveled by the roller coaster is this horizontal distance here. So like even though the movement is going from there to there, how does somebody from above view this movement going there to there? That's that horizontal distance. So the goal here is to find the horizontal distance. Well, same thing as always. We've got this labeled here. So we got these numbers on here. This is hypotenuse. We'll label that as opposite, and that's adjacent then. So which ratio uses opposite and adjacent? Okay, so that's our solving method up here. We can set it up with a tangent. So the tangent of 60 is equal to 195 over x. Just like with our other solving, we multiply both sides. We'll multiply both sides by x, divide by tangent 60 here. So this is what would go in my calculator, 36 divided by the tangent of 60. Do that, you get 112.6. So that means that's my final answer, which is 112.6 feet. Now remember, I do have 60 degrees. So that means I could have set this up with a 30, 60, 90. Okay, so 30, 60, 90. Okay, 1, 2, and root 3. I'm still using tangent. So if I look at the tangent of that, tangent of 60 is going to be opposite root 3 over the adjacent 1. So that is root 3 over 1. So as an alternate, I could have done that. Root 3 over 1 equals 195 over x. Only works if I have one of my special right triangles. So I cross multiply, I get x times the root 3 equals 195. Divide by root 3, and I get 195 divided by root 3, which is approximately equal to 112.6 feet. Okay, just two options, just be aware of those. Now, sometimes I can't do that. So for example, here, okay, golfer standing at the tee, looking up to the green on a hill. The tee is 36 yards lower than the green, and the angle of elevation from the tee to the hole is 12 degrees. From a camera and a blimp, the apparent distance between the golfer and the hole is the horizontal distance. So again, that is that distance right there. Find that horizontal distance. So just like always, label everything here. We got hypotenuse. This is going to be opposite, and then this will be adjacent. So we know the opposite. We're looking for adjacent. So once again, let's do tangent. So I can do it as the tangent of 12 is equal to opposite 36 over x. So I multiply both sides by x here. So I got x tangent 12 equals 36. Then I divide both sides by tangent 12. Okay, so what goes in my calculator is 36 divided by the tangent of 12. All right, so if I do that, it'll come out, it doesn't tell me what to round to. So in this case, I'll do 2 decimal places. So it's equal to 169.37 yards. Okay. And that's it. We're just making 2 things from today, making sure we understand inverses are used for finding missing angles, and also angle of elevation, angle of depression. So again, this was the angle of elevation because we're going from the golf ball here, goes up the hill, basically like that. So from a horizontal line, it's going up as an angle of elevation. Okay, and that's it. So feel free to pause the video, try this one on your own. Draw this draw this situation out here. And then there's one more if you want to try it on your own. Okay, but that is it for today. We'll cover plenty of trig in the rest of this unit, but that's everything for 12-1 day 2. All right, take care, everybody.